Greetings. I'm Laura Hicks, the project manager for the U.S. Army Corps of Engineers for the Portland Metro Levee System. Because of the social distancing restrictions we're currently all under, the Corps and MCDD are trying something different to reach out to you. We've put together this video presentation to update the public on what we've been looking at in the way of refinements to the Portland Metro Levee System alignment, specifically along Bridgeton Road. As you know, the Portland Metro Levee System provides flood risk reduction to a leveed area with over 30,000 people living and working in the area and over $7 billion in property value. As part of the effort to modernize the levee system, the Corps is conducting a feasibility study to determine what flood risk management improvements to the system are in the federal interest. With the majority of the residents in the protected area living in Pen 2, the Bridgeton Road protection is an important feature to the residents immediately adjacent to the levee, but also very important to the residents that live in the low-lying areas of Pen 2. To review what we've completed so far, the Corps has circulated the feasibility report and environmental assessment for public review and comment. We did that in January and early February of this year. We had identified the tentatively selected plans as Alternative 5. On April 15, 2020, we conducted the agency decision milestone, where we received the approval from our division headquarters to continue refining Alternative 5. On April 28th, the Corps and MCDD held a virtual meeting with the Bridgeton Neighborhood Association Board and committed to update the entire Bridgeton neighborhood on the refinements of the alignments along Bridgeton Road. It was specifically requested for us to reach out prior to the Corps decision on the refined alignments. What we'll be doing here now is walking you through a meeting that we're having that will give you an idea of the alignment refinements for design options that we've developed, criteria that will assist in trade-off analysis of these various options, and they were based on the concerns that we heard during the neighborhood walks held on February 25th and March 4th, and in the public comments received on the draft report. Finally, we'll walk through the evaluation of the refinement of these design options against the criteria.
And we're going to begin with a discussion of the different design options that are under consideration, and then we'll move on to the criteria for which we're evaluating those. But first, I wanted to, and at the end of this, we're not actually making a decision on which alignment option we're going to go with, but this is more of showing the process of how we're evaluating these items. Let's just first give a little overview of the area that we're looking at and the problem that we're looking to solve here. So this is the Bridgeton Road area. This purple line is just the center line of Bridgeton Road. It's just a photo of a typical area on Bridgeton Road looking west. In this photo, the river is on the right side, and then the homes in the interior areas on the left. So currently, the height of Bridgeton Road ranges a bit, but it's somewhere between about 37 to 37.5 feet in our vertical datum from 1988. And the exact amount of the levee raise is still being decided upon. But in the selected alternative, Alternative 5, one of the measures that is moving forward is a raise of the levee in both Pen 1 and Pen 2. And that includes this portion in Bridgeton here. But in the tentatively selected plan that was released to the public back in January, we had shown a design height of 40 feet. So roughly a 2.5 to 3 foot increase beyond the existing roadway heights. And this height increase will pay a lot of dividends to reduce flood risk, the chance of flooding for the interior of the area, which prevents a lot of economic damages as well as potential life loss. So what we're going after today is we are looking at raising this area, but there's many different options that we have to do that raise. So first, I'm going to talk through the different options that we're going to be talking through today. There's a little bit of color coding here, but there's 7 different variations that we'll be considering. And a picture will help show this a little bit more clearly, but we're walking from alignment being the southernmost to the northernmost for the most part, where we have a flood wall proposed for the first 6 options. 7th option then does not have flood wall or closure structure, but it's more of a wholesale raise to the road. We'll talk a little bit more detail about these. Here's an aerial view. These are not detailed schematics, but for the purpose of discussion, I think they help. So in plan view, option 1, that's where there would be a flood wall with closure structures on the south side of Bridgeton Road along the curve. And when I say closure structure, that is essentially you have a permanent flood wall in most places, but you have gaps in the flood wall where we call those closure structures, because we would come in right when a high water event is forecast and essentially fill those areas in. So there would be, most of the time, these closure structures would be open, but when a flood comes, we would come in and put some steel or wood panels in there to complete the flood wall. And so it's something, there's just a couple pictures of a closure structure where you have a short flood wall here. I think this picture on the left is in North Dakota, Fargo. But then this area here is open most of the time. When a high water event comes, you place this structure in place. So option 1 would be on the south side of Bridgeton Road, basically where the curve is right now. Option 2 would be to put a wall with closures right down the middle of Bridgeton Road along the center line. That's that yellow option. Option 3 then is to convert Bridgeton Road to a one-way street and then have a flood wall just on the existing, what is currently the westbound lane of Bridgeton Road. And then there would be openings, larger openings to allow for access into parking areas. Option 4 and 5, they look the same on this figure. Let me just remind myself. Okay, so option 4 is essentially a flood wall right on the northern shoulder of Bridgeton Road. And option 4 is what was shown in the draft report in January. So we had to show something in the draft report, so option 4 was what was shown in that draft report. We're now revisiting these different options and figuring out what would work best. Option 5 is in the same alignment, but this option is we call it an expansive flood wall, or an expansive closure structure, where there's actually nothing there in place except a few holes in the ground with covers on them. And then when a flood came along, we had warning of that. Staff would come and actually erect the entire, a closure structure for the entire length of Bridgeton Road. That's over a half mile of a closure structure that would be in place. Option 6 then is pushing out the flood wall as far north as possible We're trying to be north of the parking area. One thing that I should note, and I think we have some cross-sections later, is that the original design levee was essentially right where Bridgeton Road is. The top of the original levee was where Bridgeton Road is. And over the years since that levee was constructed, these areas where there's currently parking and other uses and access to floating homeowners, that material has been placed after the levee was made. And so we call this area the overbuild. So if you hear us talking about the overbuild, that's essentially material that was placed that's larger, that makes the whole area higher elevation than it was with just the original design levee. But this material was not engineered or designed to perform as well as the levee. So more to come on that overbuild as we talk through option 6 more. And then option 7, that is not actually shown because it's not just a single line. It's essentially raising Bridgeton Road by a few feet. So that would be the 7th option. And so to just talk through each of those a little bit more, we'll show a typical cross-section. So we've been looking from an aerial view, and now we'll look at a cross-section view and show the differences between them. So this picture, just to orient ourselves, this red line is the existing design levee. So right here, this area is the top of Bridgeton Road. The Columbia River is over here, and then the interior land side is over here. And you can see also on this image that the overbuild is shown as well on this dotted line. So there's actual material fill there, but we're highlighting the existing design levee here. So this first option, the Landward crest, there's a short flood wall right here where at the edge of the south side of Bridgeton Road there at the curb. Option 2.
Brian, this is Laura. Can I ask one question?
Yeah.
So in the cross-section on the right, that dark shaded area, would that be one of the residents that you showed in the plan view?
Yeah, I believe so. This is just a typical section, but there are some homes and houses just on this land side, so I believe that dark section is one of those houses.
Thank you.
Yeah. Option 2, the Centerline, that's essentially a flood wall, this little green stub right here, right down the middle of Bridgeton Road. Option 3, the westbound lane option, that's putting the flood wall right in the middle of what is currently the westbound lane. And then the southern lane right now would be turned into a one-way street. Option 4 is putting it on the Riverward levee side, so that's just at the north end of Bridgeton Road. Again, this was the option that was shown in the draft report. Option 5, there's no real difference. It's in the same location as option 4, except now it's not a flood wall and closure combination. It is closure structure the entire way. So you don't see any flood wall, and when a high water event comes along, this closure would be intended to be erected.
Hey Ryan, can I ask you a question about that last one? This is Jeremy.
Yeah.
Are you going to mention it now, or are we going to talk about it later? The length of that closure structure. We want to say we want to talk about that later.
Yeah, let's talk about that later because we have a whole category of closures, and how that would work for each option.
Thanks. Over.
No problem. Option 6 is a little more involved, but this is a floodwall on the north shoulder of the Riverward side. So if there's a floodwall placed that's outside of what is the existing design levee, it's in orange in this slide, but this red T here would be the upside down T, would be a floodwall that would extend, it would be higher than the current overbuild. So there would be a bit of a floodwall poking out. But to stabilize this area, there would be some additional work required that would require essentially shoring up this, what is currently the overbuild. We would have to excavate some of that and make sure that the material that we place in there would serve as a competent levee and would hold back water. Jeremy, is there anything else that you want to add about this at this point?
The only thing I'll add is that we'll talk about this later when we talk about engineering performance, but you can kind of see that sheet piling there. It's the green vertical line. It's shown there in that location. You know, it could be there or it could be kind of directly beneath the flood wall. It's kind of integral to the flood wall. That's something that would still need to be determined, but I just want you to kind of have that in mind because we're going to talk about this later, and that's an important part of it.
Okay.
Over.
Then the last option is the roadways option. That would be elevating Bridgeton Road and having that slope continue on downwards, essentially to a spot where we can then end it at the overbuild and have it still be stable. On the land side, there would have to be the sidewalks and some of the accesses to the homes that are directly on the landward side of the levee would need to be modified a bit to accommodate a couple foot raise. But this is the general idea on this road raise. Nathan, is there anything else that you want to point out about this option?
There would be some kind of slightly more intricate geometries required around the intersections and also in various driveways that people have, but my analysis has indicated that it seems possible. Over.
Thank you. All right, so those were the options that we're evaluating today. So next I wanted to just bring up the different criteria that we're going to be evaluating them on. So the evaluation criteria, we were looking at 9 different categories, and we'll be doing a qualitative ranking of this. So not numbers, but just more of a, does this option perform as a three-point scale, kind of a stoplight, where green is good, yellow is fair, and red is poor performance. So for each option, we'll be looking at these different criteria and how it performs. This first option and the options, the primary considerations that we need to look at per the Corps of Engineers guidance in our federal process is looking at a solution that firstly provides the flood risk benefits that we actually think it will. In other words, that we need to make sure that this solution will actually work when there is a flood. And then 2, we're looking at what's the lowest cost option. So look, those are the primary considerations, but there are also a lot of other factors and considerations that have come up from our neighborhood walk and from public meetings that we know that we need to consider and address as well. So this first one, flood fighting, inspection during high water. This is when there is a flood, can we get out and inspect the feature, whether it's the levee, the roadways, or flood wall, and make any last-minute emergency repairs or sandbagging or whatever needs to be done. So that's this one. 2, this is the operability. We'll really just be talking about the number of closures and our ability to actually erect those closures. 3, the engineering performance. This is if we think if there's a flood wall, is it going to perform, or is it going to might it introduce potential seepage problems that would make it fail, or is it not a very stable flood wall or closure structure? That's what we'll be talking about for 3. 4 are the utility relocations. This feeds into cost a fair bit, but for any of these options, there's going to be a good number of utility relocations. 5, parking on Bridgeton roads. This has been raised often, and we need to discuss how these different options perform for parking. So are they removing spaces or making it more difficult to park? Aesthetics, this is kind of a general category of how does the flood wall or closure structure or roadways look, how does it affect the character in the neighborhood? Traffic and emergency vehicle access, are these options changing those in any material way? You need to consider if these options are vulnerable to accidents or vandalism. We don't want to put a solution in that is going to be compromised in one of these areas. And then we'll look at the environmental or cultural resource considerations and how these options affect those. So those are the different criteria that we'll be looking at. And ultimately, at the end of the day, we'll be filling out this matrix here, where we have our 7 options right here. Each row is an option that we went through, and then we had our 9 criteria here as columns. So we'll be coming through during this meeting and filling things out as green, yellow, or red, where green is good, yellow is fair, and then red is poor performance. So at the end of the meeting, we should have this filled out, and this will be what we'll be using to help us in our decision making. We will not be, again, making a decision on which option we're going with, but this will help inform the decision making. Any other questions or comments before we launch into the first category?
Ryan, this is Valerie. I guess I have a couple of questions. Is this are we comparing them to each other? Are we comparing them to what was shown in the draft report? Are we only evaluating them on their own merits against the criteria? I just want to make sure we clarify how we're going to do the evaluation. Over.
Yeah, that's a good point. We are not comparing them to what was in the draft report to the public. This really is just evaluating them on their own merit. So, for instance, in the operability category, where we're talking about closures, a rating of good would mean that we think there's really no issue at all with this option. When it comes to closures, we don't see there's no real risks or problems that come from this. Whereas a rating of red would mean that if we institute this option, the chance that it would not perform and that we wouldn't be able to operate it is relatively high. But we are looking at kind of each one as its own merit. Does that clarify?
Yes, it does. Thank you. And then my second question is just, you'd mentioned cost and technical feasibility. So are all of these similar in cost and technical feasibility, or are those criteria that will be evaluated outside of this exercise today and further refined as we continue to move forward? Over.
Yeah, I think the technical feasibility part of it will be hitting on mostly with these first three categories together. That's the technical feasible part of it, and making sure that the solution actually works to reduce flooding. The cost part of it, we don't have a separate category for that, so we will have to be considering that kind of a little bit separately from this, but there are different components of this that feed into the cost. For instance, the utility relocation. That one has a direct correlation to cost. The engineering performance, there may be rankings that we put as poor for engineering performance that could be mitigated, but it would be extremely costly. So we'll be capturing some of that cost information here. But it's true that we don't have a separate category for cost, so that's something that we'll have to be thinking about and, considering not specifically here.
Okay, thank you. This is Alex, and my final question is just related to real estate and how we are capturing if there's any, are they all fairly similar because the alignments don't change that much, or is real estate a consideration that will also have to be looked at moving forward as we continue to evaluate these? Over.
Agreed. Yeah, real estate is another part of this, and that, again, feeds into the cost part of it. So we're not exploring that today, but that's another consideration.
Ryan, this is Mark. This is just to follow up on what Valerie said. For the folks at home, when you say real estate, some folks probably have a different idea of what that means right off the bat. So I think it would be helpful to clarify that, like right now, the levee is essentially in the right of way, and how does that change with some of these options, just very generally?
Yeah, I don't think we'll get into too much detail, but for instance, let's look at the plan view. For instance, something like option 6, which goes out into the overbill, we would have to look at the property ownership of that, because that one is a wider area that we would be constructing at than something like option 4 or 5, where we're essentially staying within the Bridgeton Road area. So those are the types of real estate considerations.
Great. Thank you, Ryan. I think folks appreciate that.
I think we'll get started. I'm going to stop the sharing the screen and bring it back to videos. But I'll be filling out this matrix as we're going along. So the first category that we'll be talking about is that flood fighting, our ability to access and inspect the area during high water events. And since the drainage districts are the local sponsor and they're responsible for doing this during high water, it makes sense, I think, for the drainage districts to talk through these considerations. So let's start with if there's any overview comments that you have on the flood fighting or inspection access, you could start there and then start working through the different options. Over.
Okay, thanks, Ryan. I'll start with option one, which is the Landward option, and I'll probably turn to at the end to my colleague Kevin in case he has some additional thoughts. But in general, as we go from Landward to Riverward, during flood fighting, there's two key essentials. One is access just for the emergency responders to be able to look at and inspect the levee. During a flood fight, we're looking at traveling along the top of the levee, obviously looking out over the water on the other side, but looking back towards the land and seeing where water is seeping through the levee, the sand levee. And so it's natural that the water is moving through, and our job during a flood fight is to make sure that there's no areas where the water has broken through or started to seep and show signs of potential failure. So the more we can look at the backside of the levee, the full levee height, the better, for obvious reasons. So the first option is perhaps the most problematic, because we're adding more structure on the landward side, and if the levee or closure structures or anything restrict access to the backside of the levee, that makes it more problematic to get people and equipment down there. And so in these areas, there's already some existing infrastructure which complicate that. But if we obviously restrict road access, cut road access off, we may still be able to get back there to look by foot, but obviously that's not as efficient. And in stormy weather or in the dark, it complicates our ability to inspect the system readily. As the potential options here move towards the river, road stays open, flood fighting access is easier and easier. Equipment can get in there more quickly. So they tend to favor flood fighting a little better as we move towards the river. Kevin, do you have any things to add on that? Can I cover everything?
No, I think that pretty much highlights it pretty well. The ability to actually recover from an issue during flood fighting, where we see seeps and boils, is going to typically require heavy equipment. And so if you have something that prevents that from happening, you are severely decreasing the odds of being able to correct an issue if you observe one.
Let me just, I think I'm hearing what you're saying and put some ratings down, but want to make sure that this is right. For that first option, that is where the floodwall is right on the existing curb, the south curb of Bridgeton Road. So there's no equipment access. There's just a sidewalk. So it sounds like you would rate that as poor. Is that correct, Mark and Kevin?
Yes.
Okay. And then you said it gets worse as we get further. So number 2 was the center line of the Levee Road. So there's some area there, but it's less. It's only one lane in a small area. So it's the thought there that is not as bad. It's not poor, but it's not. There's no problem at all because there's a limited area. So that would be fair. Is that correct?
That's correct. It would just Sorry.
Okay. And then you mentioned that the rest of them, you would have full access to the land side of Bridgeton Road. So option 3 through 7 would be good. Essentially, no problems with those. Is that correct?
Those would be good.
Okay. Are there any from other people? Are there any other questions or comments on that category? I'll go ahead and just show the matrix as it stands after that first category.
Ryan, this is Valerie. I apologize. I couldn't get off of mute. I just wanted to ask, is that the access access and the issues that Mark and Kevin were discussing, is that more related only to larger or heavy equipment, or is that really kind of any concerns with access? I'm just trying to distinguish, how they maybe get heavy equipment into flood fight versus just kind of more, typical vehicle traffic.
Oh, yeah, good point. We'll be talking about typical vehicle traffic and some of the later ones. This is really when we have a really large flood happening, do we have the ability to inspect the floodwall or levee and make any emergency repairs? So it is more about that equipment access.
Yeah, and it also has a little bit to do with safety and just patrol vehicles will basically be like pickup trucks, and they'll need unimpeded flow. But if it reduces to a single lane, that's not a big deal for the patrol vehicles. Of course, at that point there probably won't be very much traffic at all, or shouldn't be any. It will be evacuated. But we start to get that sort of yellow, that sort of fair performance when we start to neck down the travel lanes for the heavy equipment that might need to come in and do some flood repair and that sort of thing.
Does that answer your question, Val?
Yes, it does. Thank you.
Yeah. Okay, any other thoughts or questions on this category? Let's move on to the next topic. That is operability, or the number of closures. All right, let me get my screen going again here. So this is, we talked about closure structures. These are essentially gaps in the flood wall or levee they're gaps 99% of the time, but when we do have a flood, we need to be able to get in and fill in those gaps so that we can make sure that we actually have an unbroken flood wall that will hold back water. And one of the things that did come up on this was there was some concern about if we put these closures in, is that going to cut off the ability of folks in these floating homes to evacuate? If the closures come up and there's a solid wall at that point, is there an ability to still evacuate? And yeah, any of these closure options, the intent is not to increase risk. So a kind of an add-on with these closures to ensure that folks from floating homes could still leave safely would be to have some type of access ramp or stairs or something of that sort to make sure that folks in floating homes can leave the area and not be blocked in by a closure structure. So when we think about closure structures, the operability, we have to think about the primary thing is there enough time and is there enough labor to construct the closure and fill it in before floods come. From what we've seen, the primary types of floods that we are defending against, we have these, it's mostly, when we're talking about extreme events, it's mostly a wintertime event. Something along the lines of the February 1996 flood, but just larger. And those types of events, we have some warning. We went back and looked at what the Weather Service, the River Forecast Center, actually issued for their forecasts for the 1996 event. And what we see is that there's some advance warning of this, but it's not weeks and weeks of warning. It's more on the order of days. So from that 96 flood, we essentially had 2 to 3 days of warning that this was really going to be a large flood. So it's not an extremely long amount of time. This spring snowmelt floods that we've seen in the past, like 1948, those types of floods, there's a little bit more warning. You can see that one coming. It's a little bit more gradual rise. So that's not quite as critical for the operability or closures. It's these winter kind of short, fast-moving events that come in that are more challenging. So I'll go ahead and talk through each of these options at this point. Let's walk through the different options now and how they perform for these closures. So option 1, that was on the landward side. That was at essentially where the curb is right now on the south side of Bridgeton Road. This require quite a large number of closures, essentially a closure for every cross street that comes in, and those would be relatively wide closures, 30 feet or so. And there's about 6 or 8 of those road closures. And then there would need to be closures for the different driveways of folks as well, so that there's not a wall cutting off access to that driveway. So if the wall and closures are on the south side, there will be a lot of closures, and it is challenging to mobilize staff. During these high water events, there's a lot of other items that also need attention. There are other closures that need to be installed throughout the rest of the system, and the more closures that you have, the more storage that you need to have for the different pieces that you use to create the closures. So on the south side of Bridgeton Road, there's going to be many closures. So I would rate this one poor for the south side of Bridgeton Road. Where you have the center line of the road, so option 2, you would only need closures at the cross street. So it's less closures than the first option, because there's no driveways to contend with. But that's still a number of closures. Right now in the system, in the whole Portland Metro levee system, there's only a few closures throughout the whole system. I think there's about 6 or 8 for the whole system. There's Floodwall up in Penn 1, and then a few others. This would be essentially close to doubling that, which is going to be much more challenging to do. And there needs to be exercises of these closures as well. So the center line of the Levee and Road, there's less. That does seem like that is doable, but it's still not a slam dunk. So that I'd probably put as fair as well. Similar case for number 3, that's the westbound lane option where Bridgeton is converted to runway. Essentially, a similar number of closures. You don't have closures for the cross streets, but now you have closures for all of the parking areas to get in and out. So that one is fairly similar. Probably rate that one about fair. So option 4, that's on the Riverward side of the levee, so the north side of Bridgeton Road. Now that was what was shown in the draft report, and that one, to accommodate and not block off access to the boat ramps and the parking areas, that's going to require quite a lot of closure structures, essentially analogous to the number that was in option 1. So that one, and they're all going to be a little bit different sizes. So that is going to require a lot of closure structures, and that would not have fully reliable performance there. That one I would rate poor because there are a lot of closures there. The fifth one, this one is probably the most, requires the most discussion. This is the Riverward crest with, it's the pure closure structure option. So this is the option where there's essentially no flood wall at all. It's just a closure structure. There are some closures like this throughout the country. We did some research on other areas throughout the nation that the Corps has done levee improvements at. And there's actually a national levee database that the Corps maintains of all the levees in the nation. And we looked at where do we have the longest closure structures. Is what we're proposing here really out of the ordinary or out of normal? And from what we saw there, the answer is yes. This would be, if not the longest closure structure in the nation for a Corps levee, among the very top, because we'd be looking at over 3,000 feet of closure. So this option, well, there are obstacles to getting this really large closure in place in a way that we think would perform well. So the best analogy I think that we have, I will share the screen at this point, is this closure in Louisville. It's at a baseball field, and it's this one at the right, where it's about a 600-foot long closure. It's a little bit higher than the closure that we're proposing here. We're looking at about 3 feet or so, somewhere around there, where this one was more about 4 or 5 feet. But yeah, that was about a 600-foot long closure. They put in these vertical posts and then filled in with steel or wood beams to create the flood wall. And that exercise, some records of their test exercise look like it took them about 25 trained staff members, an 8-hour full day of work to erect the closure, and that took a couple pieces, a couple forklifts, and a couple trucks to bring the pieces of the closures around. So when we're looking at our system, something that's going to be about 5 times longer than this one, the numbers add up. Well, it would require a large amount of effort to do this in time when we have only a couple days of real warning that overtopping is actually going to happen. So that's one example. I think the other piece is, well, here in Portland, on the waterfront, Veers Wall, back in '96, this is another one of those really long closure structures in the nation, where the idea is that you put up panels at the waterfront. And actually in '96, we were looking at this, and they couldn't find the pieces for the closure. They had to go out and find some alternate sources and had to kind of jerry-rig it together. So that's another risk of this, is there's a lot of pieces that are needed for this. Keeping those maintained straight is a challenge. Jeremy, I don't know if you had any other thoughts on this option.
Over. Yeah, thanks, Ryan. This is Jeremy. I think it's a challenge, this option. I think for the reasons you mentioned, and it's kind of, it takes a lot of people and a lot of equipment to install this long closure. And so it's really labor and equipment intensive, and we've been committing a lot of energy to installing this thing. At the same time, there are a lot of other things happening. A flood is coming, and there are other things to be done in the system, and this would take a lot of energy to do this. So I think that's an issue with it as well. Over.
Yeah. Okay. So after all that discussion, I think that this one, the performance would be rated poor, just for all those considerations that we just discussed. The last couple, if we did the north shoulder on the river side, so that's on the overbuild, having a flood wall and closures, we really just need closures for the access ramps to the floating homes. But that's still, I think there's roughly 20 access points there. So that's still a lot of closures. It's not poor. I think that but it's not no problem at all. So that one is probably rate fair. And then the last one of raising Bridgeton Road, of course, in that case, there's no closures required at all. So that one we would rate good. Let me bring up the matrix as it stands right now after 2 categories. Okay. I apologize for being a little long-winded on that category. Let's move on to number 3, the engineering performance. I think I'll have Jeremy talk through these ones.
Okay. Thanks, Ryan. I'm Jeremy Britton. I'm a geotechnical engineer on the Corps PDT, product delivery team here for the study. Before we start talking about the engineering performance for all of these, I just wanted to kind of remind folks that cross-section that Ryan showed, where we have the design levee section, which is what we consider to be the levee, and then there's the overbuild material, which is on the Riverward side, and it's material that's been placed over time for things like parking and other things. And we don't know as much about that material. We don't know how well it was compacted, if at all. And when the sponsor hired an AE firm, an engineering firm, to do some exploration, to drill some holes into the levee for the recent assessment. They drilled holes in the levee and down the Centerline, and then at the toes of the levee, kind of on the Landward toe and then on the Riverward toe. But there weren't any holes drilled in that overbuild, and that's because that's not really part of the levee, so there was no real reason to explore that material. So we don't really know as much about it. We do have some experiences with it over time that there have been incidents of that material sloughing, which is kind of like just shallow sliding, down into the river. So that's just an observation about that overbuild material. That's a little bit of context. So getting into these various options, and we're going to talk about engineering performance. So it's things like Ryan mentioned earlier. We're looking at seepage underneath the flood wall and the impacts of that, and also the stability of the flood wall from tipping over when there's a flood. So for option 1 there, where the flood wall would be placed on the kind of landward shoulder, the south side of the road, the thing about that one is there would be a slope on the landward side of the wall. The ground would be sloping downward away from the wall, and so that So when there's seepage beneath the wall, when there's a flood, there's going to be water seeping through the ground, and it'll want to be emerging on the landward side. And if you have water coming out of the ground, I think the thing, maybe the image to have in mind is a sand boil. A sand boil is kind of a bad thing to have happening during a flood. And when you have seepage coming out on a slope, it's easier for internal erosion and sand boils that would kind of cause erosion and erode the ground underneath the levee. It's easier for that kind of thing to happen than if seepage is coming up in more of a vertical direction. It's coming up vertically onto where there's flat ground. So the fact that there's that slope there is not really good for seepage performance, internal erosion and piping. And it's also not as good for stability because the ground is sloping away from the wall, and so there's less ground there to provide support for the wall against tipping over. So I think for that first one, the wall located on the south shoulder, I think we should rate that one fair, because they're probably, we could design the wall to address the issues that I mentioned, but it's not the best place for a flood wall. That's not where we would ideally place a flood wall. So I think fair is a good rating for that option. Moving to the other one, I think maybe I'll kind of talk about options 2, 3, and 4 all together. These ones, now the wall is moving farther to the north, away from that shoulder and that slope. So now there's more land or ground on the landward side of the wall to support it. So I think those are all, those are kind of normal places where we put flood walls down the center line of a levee or on the Riverward side. So I think option 2, Centerline of Levee Road, that's good on the existing westbound lane. Option 3, I think that's also good. And option 4 is also good. Are there any comments on those 3? Okay, so moving to option 5, this is the expansive closure structure option. I think for this one, we already talked about operability. That's getting the closure constructed, getting it in place. So I think we have to kind of assume that that's happened. And now it's just what's the engineering performance of the wall, the closure in place. And this one, it could be, if it's all put together properly and everything's just perfect, it could be good. But I tend to think this one might be more of a fair rating just because it's a really long closure and we're going to be putting it in place in a hurry, most likely, and there's a chance that there could be folks working on this that haven't done it before just because of the number of people involved and turnover and things. And even though we're going to exercise putting this thing together many times before the actual event, I just think that there's a chance that there's maybe a flaw in the construction of the closure. Something doesn't get installed exactly right, and it kind of threatens the performance of the wall when it has to take the flood. So I think fair might be a good rating for number 5. Are there any comments from folks about that? Over. Okay. well, let's go to number 6 then. For number 6, this is the flood wall that's out there on the north shoulder. And I think it might be good when, as I'm talking about this one, if we can show the cross section so folks can kind of see what I'm talking about on this one. For this one, we're building the flood wall in that overbuild material that I was talking about before. And because we don't know as much about that overbuild material, we don't really want to build the wall inside the overbuild as it is. So we would probably excavate some amount of that overbuild and replace it with compacted fill so that we know what we're building the wall in. But still we have this issue where that flood wall is kind of perched on top of the overbuild that's farther below that we weren't able to remove. And I mentioned before that there's a kind of a history of sloughing or shallow sliding of that overbuild. So as that overbuild tends to slide or slough, that would kind of cause the ground there to shift, and our flood wall might kind of tilt or kind of lean a little bit for the riverward side, as the ground is moving away from it in that direction. And there's a possibility of some structural damage to the wall when that happens. We had that sheet piling in the section, and the sheet piling could either be where it's shown there on the cross section where it's kind of out closer to the river, or it could be beneath the flood wall itself. And the purpose of that sheet piling would be to kind of try to hold the ground. If there is sloughing of the overbuild material on the riverward side, we would want to try to kind of hold the ground and not have our wall tilt to the left toward the river in that cross section. So that would be just an engineering challenge that we'd have to do for that. And I guess the bottom line is, if we go with this option, it's gonna involve the flood wall not only having to resist the flood load, which is wanting to push the wall, toward the landward side when there's a flood, but the wall also has to be able to stay stable and steady if that overbuild material that's on the riverward side sloughs and we lose support on that side. So it has to kind of work in both directions. Okay, that's number 6. So I think in the end, maybe fair is a good rating, and that kind of reflects the fact that it would be more costly maybe to make that one work. Are there any questions about that one? Over. Okay, the last one, number 7, raise Bridgeton Road. That one I think is good. I think that's kind of a good rating for engineering performance. It's pretty easy to evaluate. We're just raising the entire section there, and it's not really a challenge from an engineering point of view. So I think that one is good. Over.
All right, thanks, Jeremy. I've been transcribing your ratings. Are there any other questions or thoughts before we move on from this category?
This is Mark from MCDD. Appreciate you going through all those things, Jeremy. Lot for people to digest, but on that last one with raising the road, I think it would be kind of an exciting option. Obviously, there's some challenges to that anytime you work in the public right away. So I think it's important for the public to know that this is obviously a big exercise in trying to show people all the trade-offs, and that one, all these things have a lot of pros and cons, and some of the things we haven't talked about are the implementation pros and cons, and being able to do some of these things in public and private space. So, but thanks for going through some of the details.
Yeah, you're welcome. Were there any things that I talked about that could be clarified for the audience? Over.
I think, maybe a quick summary of what is more of an ideal condition for the flood wall if one is to be constructed. Jeremy, may be appropriate at the end, just to sort of help clarify what we went over. Is effectively pushing this wall too far to either side of the levee embankment is not ideal, and having it somewhat more centered or shifted slightly toward the riverward side provides what we would consider the best soil conditions and for the flood wall to perform optimally. And then with the last option being a complete road raise, at that point, we have good soil conditions as well.
Yeah, actually, I think you said that well, Kevin. You want me to kind of reiterate, or we could just? You said it very well, I think.
Yeah, that's fine. I'm fine with that.
Thank you for that input.
Okay. I think that wraps up category 3. I'll share the current state of the matrix at this point with the ranking. Okay, next category is utility relocation, and how each option performs under that. And I think I'll ask Nathan to talk about this. Nathan is our civil engineer on the project.
Sure. Thank you, Ryan. My name is Nathan Storms, and I'm a civil engineer with the Army Corps, for those of you out there. So in the construction of any of the potential flood walls, closure structures, and the road raise through the Bridgeton area, we would be running into a large number of existing utilities, as one may imagine, because this is a fairly heavy residential area. Particularly, there is water, combined sewer and storm sewer, and gas that are the 3 main, in addition to telecommunications and power. Electricity is a little bit less of a concern because it is primarily above ground in this area, and telecom is kind of a mixed bag. So when it comes to utilities, we're really kind of focusing on water, wastewater, and gas as being the 3 big ones that will have impacts. The reason that utilities are concerned for the flood walls and the levee overall is because for any sort of flood wall where we would have a kind of a subterranean sheet pile to kind of act as an underground prevention of water migration. Those would need to have utility penetrations in order to allow service to continue, or utilities would have to go above ground in some fashion to go up and over the flood wall. Also, for kind of all of the options in the existing levee as it currently exists, the utilities act as a kind of a possible pathway for eternal erosion, but that's just a fact of life. That's kind of where we are at the moment with the utilities in the levee. So looking at our 7 potential options, when it comes to utility relocations, kind of the existing utilities, the impacts we would have, most of the flood wall options, really 1 through 5, which is kind of a flood wall just at various alignments or various locations across the levee crest and the road, are all going to have kind of the same problems. There's an existing, there are mains basically that run underneath Bridgeton Road in the center and the north side primarily. And those mains serve both the Riverward homes and houseboats and the Landward homes and businesses. So any sort of flood wall that we put either on the Landward side, the center, the Riverward side, is going to basically end up with more or less the same number of utility penetrations. It might vary in some degree depending on where the exact location is, but for the most part, it's going to end up having a lot of impacts. You're going to have a lot of various penetrations in that sheet pile wall. So for the Landward, Levee, and Road crest alignment 1, I would rate that as poor, just because the number that we're talking about. I mean, just to give some perspective, I believe my last count, I think there's something in the order of over 200 when you consider water, wastewater, and gas in this area. So that's a lot of levee penetrations we would have to deal with, or sheet pile wall penetrations we would have to deal with, flood wall penetrations we would have to deal with. So I would recommend rating it poor for the Landward Levee option 1, the Centerline option 2, the existing westbound lane option 3, the Riverward Levee crest option 4, and so those are all the floodwood structures. The expansive closure structures would be the same, because even though the surface would look different, because we wouldn't have a permanent flood wall, we would have closure structure that we would erect in times of need. The underground portion of that would be the same. We would still need the sheet piles for cutoff, so we're still having to deal with all of those utilities that run through there. Either realigning, doing penetrations through, running a separate main so that we have a main on either side of the wall. Those are kind of your options. So that would be the same for option 5. Pardon. For the north shoulder on the Riverward side, option 6, things are a little bit better for a number of reasons. One of which is that the utilities are generally deeper as you move towards the river, because they're underground and going down the levee, and so there's a possibility we'd have fewer conflicts. Also, as you get towards the houseboats, a lot of the utilities kind of collect and run down on the surface, down the ramps that lead to the docks. So those would be easier to handle once they're kind of more in a centralized location. And then some of the bigger storm sewers and those types of things are potentially impacted when we're talking at the top of the levee crest, but we expect them to be well below where even the sheet pile wall would extend when you get out into the overbuild quite a ways. So because of those items, I would recommend option 6 being fair when it comes to utilities. There would still definitely be impacts, but it would, at this point, it's seemingly fewer impacts than options 1 through 5. And then option 7, which is the raise of the road, obviously we would eliminate all of the kind of need of a sheet pile wall, but we do run into some additional difficulties, or different difficulties, because if we're raising the Bridgeton Road a certain number of feet, we will have to basically add risers to all of the surface expressions of those underground utilities. So every valve cover, every manhole, everything will need to be extended the same amount of feet up to surface. That might even hold true for like valve stems and those types of things that you need in order to operate the utilities. And so that's kind of because of the large number of those, all of the various access points and surface expressions of the utilities, it's kind of, I go back and forth. I'd say fair to good, because obviously adding risers is easier than trying to do all of the flood wall penetrations, but it still will require a large effort. So fair to good on number 7.
Let's move on to parking on the north side of Bridgeton Road. I think we'll have Nathan talk about that again. So, yeah.
Okay.
Parking impact.
I'm not on mute, am I?
You are not.
Okay, good. I couldn't remember if I had or not. Yeah. Okay. So one of the other items that we looked at in our table here is parking. I know that parking is a big concern for the residents in the area, and so we wanted to take a look at the various impacts that these flood wall options and the roadways option might have on the available parking in the Bridgeton neighborhood. I think there's not really a whole lot more to say about that. Everyone knows what parking is. The idea is to try to eliminate or reduce any sort of impacts that we will have to parking, primarily focused exclusively on the north side of Bridgeton Road. There are a few places on the south side where it appears that people park in a parallel parking fashion, but those are very limited. And so our focus is on the north side, as that is the vast majority of the parking in the area. So just kind of walking through these. Option 1 being the Landward Levee Road shoulder crest. That would be rated as good. There's no impact to the parking on the north side of Bridgeton Road, as the wall would be on the south side. It may end up eliminating 1 or 2 parallel parking spaces, I mentioned just a moment ago, but I don't think that would knock it down from a good. I think on the whole, it's still good for the parking on the north side and the parking overall. The center line of the road floodwall, again, that would be good. It has no impact on either the north or the south side. So the parking on the north side would be preserved. The only impact it would have would be in traffic patterns, which are discussed in a different topic a little later. Westbound conversion to one-way road, westbound lane floodwall location. That would result in the elimination of a few parking spots just through basically the sheer geometry of it. Some of the parking spaces right now are shorter, and they require vehicles to back out onto the road in order to go in and out of to leave the parking space. There would conceivably be a frontage road for parking on the north side of that wall, but there would be a few places that are just too tight that a parking that currently exists would no longer be really feasible in those areas. A flood wall on the Riverward crest, so on the north crest, I would rate as poor. Option 4, where the flood wall is located on the Riverward north shoulder of the road, I would rate that as poor when it comes to parking. It would not allow for a lot of the parking spaces to be accessed without closure structures. There isn't really a lot of room there, so a frontage road to access parking wouldn't be feasible in a lot of locations. So it would likely result in the elimination or reconfiguration of a lot of parking spots. Option 5, which is the Riverward crest expanding closure structures, I would rate as good because the intent of that option is that we would have closure structures instead of permanent walls. So except for when the walls were up during active flooding, there should be no impact to the access to and from those parking spots. Option 6, which is the north shoulder out in the overburden, or the overbuild, excuse me. That's entirely different. Is good. It would be on the north side of the parking, so there would be virtually no impact to the parking spots in that area due to construction and the feasibility. Some of the spots might be shortened, as there are some double spots I know in the area. A few of those double spots might need to be changed to long single spots. But on the most part, there would be little impact to parking, so I would rate that as good. And option 7, the raise of the road, I would also rate as good. That option basically included a raise of the road, but also a raise of the parking area. And so a lot of the parking areas would be shortened because depending on the amount of feet of raise the road undergoes, we would need to slope down at the riverward edge to meet the existing grade of the overbuild. But for the most part, it looks like in those locations, it would just be a reduction of a couple of feet. Sorry, for most locations, just be a reduction of a couple of feet. So the parking space would be shortened. A couple of the double spots might be shortened to a single spot. But on the whole, it would have very little impact to the amount of parking that is available. So I would rate that as good as well. Any questions? Over.
All right, next is aesthetics, kind of the visual and feel of this. We'll turn it over to the local sponsor of the drainage district. They are most in tune with the area.
I'm Brian. Thanks again. When it comes to aesthetics, obviously there's a couple things to consider. One very important consideration in all these things is, in some cases, there will be permanent structures in place, and in some cases there'll be temporary closure structures. And obviously we haven't arrived at any decisions, but some of these have more or less a visual impact. And there are things that we can do once we get into the true design phase and figure out which alternative is we're narrowing in on. There are things that we can do as local partners to try to further enhance the aesthetics of some of them to a limited extent. But some of these options do address aesthetics or don't really have a consequence except during high water periods. So I'll talk a little bit about that. The Landward road crest, southern road crest levee option or floodwall option obviously puts a short structure directly in front of homes. And in some cases, those structures can kind of be integrated, like let's say to look like more of a retaining wall or a wall that you might have, or a fence that you might have in your front lawn. So they would obstruct the view a little bit, but they might be integrated into the space there so that they don't have a visual impact, and maybe even they add to the utility of the frontage of the house. Option 2, when we talk about the center line of the road, and we see that has been a concern to some people to have a permanent structure in the center of the road. We'd say that it's pretty fair. It is an adjustment, and we don't know at this point what the elevation of that structure would be. So we know that it'd probably be somewhere on the order of between 2 feet to sort of waist high at the maximum. So some folks have these images of a very tall wall occluding like their view of the river. A lot of people move there to see the river, and that is not the intent of this project, is to disrupt folks' view out to the river. Option 3, again, is to put a wall in the middle, sort of in the right-of-way, and it would create a one-way road. So again, it's basically in the middle space of the road where people would see it when looking out. So it's similar to the previous one. It's fair. It's not the most aesthetically pleasing, but again, it's important to consider that we're not building a 6-foot or 10-foot wall. We're talking about a wall that would be sort of waist high and perhaps much lower than that. We're still in the phase of trying to balance the cost and other factors, as well as our modeling to figure out exactly how tall the wall needs to be to provide the protection we need. Option 4 is a Riverward levee and road crest shoulder. So it's a little further away for the folks that live in, say, places like the Bridgeton condos. Obviously, the further the wall gets away from them, the lower the visual impact or the obstruction that it would have. So it gets a little bit better, but it still does split the area in two. So there are trade-offs. Option 5 is a Riverward crest flood wall with a series of expansive closure structures. So notwithstanding the performance concerns or evaluation criteria for a temporary closure structure, this is obviously going to have a much lower aesthetic impact, because you're not going to see these walls except during those extreme high water events. So MCDD has a flood fighting plan, and that flood fighting plan, which is available to the public, is very prescriptive, and it shows at different flood elevations when we would activate certain flood fighting measures, when these closures would go into place. And if you were to look at that, you would see that, you know, only in the more extreme events would these closures go into place, and they would be up for, you know, depending on the flood event, you know, a matter of days, at most probably a matter of weeks, based on historic storm events. And so these structures probably wouldn't get put into place, but for every few years or perhaps decades or so. Our last high water event of concern was in 2017. Our last significant high water event was in 1996, and that was where the river almost came over top. So trying to give you a sense of how often these things would be put into place and how often they would be impacting the view. But so obviously a temporary closure structure, if feasible from an engineering standpoint, is going to have less visual impact. And so that I would call rate good or green. Then we have option 6, which is the north shoulder on the riverside. And again, now we start to have sort of kind of impacts to other users. So we have townhome users on one side of the road who have certain concerns, and on the north side we have floating home owners that they want to be able to see their cars. So depending on the elevation of flood walls, you know, they may or may not be concerned about being able to see their vehicles parked, just from a sort of a safety, security standpoint. Now that, again, we don't know exact height of the wall precisely. It's going to vary as we go through our design optimization. So in some cases, there's an 18-inch curb there already, so the impact may not be much greater. But again, as we get Riverward, it starts to become a little more fair for some users, and it becomes much better for the others that are on the south side of the street, because they'll be able to see over that wall a lot better. Option 7 is the raising the Bridgeton Road option, and obviously some folks that live along Bridgeton might be concerned, you're going to raise the road, how much higher? When I step out my door, what am I going to see? You saw some sketches before, some cross sections. This is an option that would be possible if we found that raising, that the levee raise might not have to be so high. And it's kind of amazing how you can kind of make up that grade. So if the levee only needed to be raised, you know, a couple of feet versus, say, 3 to 4 feet, this is going to be more possible. And then obviously this is going to probably be the most seamless aesthetically. You're not going to see any new structures. There will be a temporary disturbance during construction, and the road will be a little bit higher. There may be some minor adjustments at the curb line and at the interface of the townhomes, but that could all be kind of smoothed out. So this is going to have the least visual impact and would probably be somewhere in the fair category. There's some pros and cons to this option as well, depending on how it gets designed.
Okay. So if I heard you right, it sounded like the option 5, the expansive closure structure, that really is no change from today. So that one was good, but all the other ones, there was some pros and cons, but nothing stand out as way worse than the others. So it seems like fair was what you're going at with all the other ones.
That's fair to say.
All right. All right. We're getting there. Let me flash up the content, the matrix as it stands right now. There it is. All right, let's move on to traffic and emergency vehicle access. Impacts there. So, yeah, we did hear from residents in some of the public meetings that emergency vehicle access was a concern for some of these options. So we wanted to make sure that we evaluate that. So, yeah, I'll turn it over to Nathan to talk through this category.
Okay, thank you, Ryan. So looking at traffic patterns and emergency vehicle access in the Bridgeton neighborhood, I think everyone probably understands what we're talking about. We're talking about the use of the road as a road, and also the ability to get large vehicles, primarily ambulances and fire trucks, into that area if needed. Any other type of large vehicles for other emergencies was kind of discussed with the flood fighting aspect of it. So, that being said, for option 1, the Landward levee crest floodwall, don't believe that there would be any impacts to traffic patterns or emergency vehicle access. Openings and closure structures at the intersections, but those would be open most of the time, and the walls would be stopped the closure structures would be large enough so there would be no impacts to the kind of the turning radius, the swept path of the larger fire trucks and those types of vehicles. So I think that would be good, rated as good. Alignment option number 2, the center line of the Levee Road. This is probably going to be poor. By making a flood wall, by putting a flood wall in the middle of Bridgeton Road, basically making 2 narrow lanes that do not communicate with one another. And so that would likely lead to basically disruption of emergency vehicle access to that area because they wouldn't be large enough for the larger vehicles to traverse. It would also, as far as just traffic goes, it would lead to some odd for residents as the openings in the wall would likely only occur at intersections. So in order to get to your house, driveway, or parking spot, it would probably require a lot of driving past and then doing a U-turn and going back in, which would be cumbersome. It wouldn't be the end of the world, but I'm sure they prefer not to. Option 3, which is basically putting it in the existing westbound lane, that I would also label as not necessarily because I think the lane would be large enough for emergency vehicle access. For the most part, the problem would be the one-way traffic that would necessarily incur, and so if you live on Bridgeton Road, you would always have to leave going one way and then turn around and go the other, either coming or going, which just makes for complicated traffic patterns, the disruption of traffic not only on Bridgeton Road but also in the side streets. There'd be a lot more traffic on all of the various side streets, which would have impacts. So that's kind of a poor, or maybe a poor to fair, because it's more of a living thing versus a life safety thing. On the Riverward Levee crest, option 4, I think that's the same as option 1, really. It shouldn't have any impact to the traffic patterns. People can still drive on the road as they do now, and emergency vehicles can still drive on the road in the manner they do now, so I would say that's good. Option 5, with the closure structures, expansive closure structures, again, that's very little change from the current condition, so I would say it would be good. Option 6, which is the north shoulder, the flood wall is so far removed in most locations from the traffic flow that it shouldn't have any impact, really, on vehicle traffic in the area, so I would rate that as a good as well. And option 7, the road raise, there appears to be sufficient amount of space available for the road to maintain its current width, so for 2-lane traffic. And so I would rate that as good because it does not change the traffic patterns at all. If in the further investigation of that option, it becomes necessary to reduce the road to one-way traffic due to a narrowness of the roadway, then that would be reduced to fair probably. But as it currently stands, I would say that the road raise option would be good because it would maintain the existing condition. Over.
Okay. Any questions for Nathan?
Nathan, this is Valerie. I guess just, I think what I heard you say on a couple of those is that response time might increase. For example, if it's a one-way road, an ambulance driver might have a longer response time because they have to take maybe a different route than the more direct route or something like that. Would that be a fair statement? That
would be a fair statement. Sorry, didn't mean to cut you off. Yes, I would say that would be a fair statement. If there was in a certain location, it required in a slightly altered traffic pattern in order to reach it on using the one-way street, then yeah, it would require a longer response time for both ambulances and fire trucks and police, for that matter.
Okay, thanks. And then my other question on that was just, does any of the alignments change? So when we were out doing the neighborhood walks, one of the things was just, say someone has a heart attack and the wall would impede their ability, a response, say, of an ambulance to get maybe a gurney to their front door and in the house, or, from the ambulance or anything. So do any of these, say, impede access for emergency responses? Over.
I'm going to go ahead and say no. I would like to preface that by saying that we are currently in the feasibility level of design, but we will be, when the option is chosen and we start developing the design to a more advanced state, we will be complying with all of the various requirements and recommendations and laws and regulations when it comes to those types of things. And so I'm operating under the presumption right now that the intersections and sidewalks would be ADA compliant, and such things as the closure structures would be wide enough to fit any sort of emergency services, such as a gurney that would be required. I can see a scenario where the ambulance would be parked on the street versus being parked in the parking area right now, depending on where the closure structures are, but they would be plenty of access for all of the equipment that was necessary to get to that person. That wouldn't be restricting us. We would make sure to design that out, I guess is what I should say. Over.
Okay, thank you.
Okay. Going to flip back the matrix as it stands right now. And that's next. This is taking a while, but thanks for hanging in there, guys. Important. So, yep. So this was our ratings from the traffic and emergency vehicle and emergency responders access as well. Okay. Moving on to the vulnerability to vandalism or accident. I think I'll hand it over to Jeremy to speak to this one.
Okay, thanks, Ryan. In terms of vandalism, let me just say something overarching about that one, I guess. I think all of the options that involve flood walls and closure structures, all those features are subject to vandalism, really, kind of no matter where they're located. The one that isn't really subject to vandalism is the road raised, because the road is just raised. It's kind of hard to vandalize that. In terms of accidents, kind of there are two things to think about here. One is just you're driving down the road and you crash into the wall. That's one kind of an accident. Another one is you're trying to park, or you're trying to, maneuver around the parking areas or on either side of the road, and you hit the wall trying to park. So for the first one, let's go one by one. Option one on the landward side shoulder. There's probably not going to be, you're probably not going to hit it driving. There are some closure structures at driveways, so there's an opportunity for hitting the wall there. I guess this one could be fair or good. I think good is maybe, we'll go with good for this rating. There aren't as many. It's less. You're less likely to hit the wall, I guess, here than on the north side, where there's a lot more pulling in and out of parking spaces. So I suggest we rate this one good. Moving to the next ones, and kind of like I did for engineering performance, actually I'm gonna kind of lump 2, 3, and 4 together. While it's good to have the flood wall kind of in the center, or toward the riverward shoulder of the levee for engineering performance, having the flood wall down the middle of the road or to the north a little bit is kind of bad for traffic. If it's right down the center of the road, it's likely to be hit by vehicular traffic at some point in time and potentially damage the wall. So I think number 2 is poor for that reason. Number 3, where there's the one lane option, probably poor for this one too. The wall could be hit, and there's going to be a lot of times when cars and trucks and things are going to be pulling in and out of all that parking that's on the north side. So a lot of opportunities to hit the wall when they're going through those closure structure openings. So I think for that reason, kind of 3 and 4 are probably poor. 4, again, for the parking, people pulling in and out of there, there's a lot of good chances of hitting that wall when going through those closure structures. So I think 2, 3, and 4, I would say, are 4. Number 5, the Riverward crest, the expansive closure structures. So now, because it's mostly open all the time, there's not really anything to hit, which is good. There's another set of issues. One is that there are going to be holes in the ground where posts will be placed when it's time to set up the closure structure. And there's an opportunity for those holes to get filled with earth material or junk, or somebody forgets what it's there for and they fill it in with something by accident. So there's a chance that there's those holes that are really critically important for setting up the closure could get disturbed. So I think for that reason, that's something that can be monitored and watched for, and probably mitigated to a large extent. Maybe we'll just call that one fair. I don't know, that doesn't really seem to rise to the poor level in my mind. So I think that one's probably fair. Number 6, the floodwall on the north shoulder on the riverside. This one, so there won't be any cars driving parallel to the wall because this is the one that's kind of on the northern shoulder of the overbuild there. Maybe this one would just be fair because there's just there's a potential for cars that are parking either forward or backing in to hit the wall when they're parking. That happens from time to time. People hit things when they're parking, So there's, especially when backing in, so there's a potential for the wall to be hit during parking. So maybe that one's fair. And then I think the last one, raising Bridgeton Road, number 7, that option, that's rated good. There's nothing to hit there. It's just a road. Are there any questions or comments about those suggested ratings?
Jeremy, I know this is Valerie. This is a detail maybe, but just And I understand the rating with, someone maybe backing in or hitting the wall accidentally, but I mean, is an option to put in those kind of, poles or whatever that would prevent someone from damaging the wall and hitting, those kind of poles. So, in other words, are there some design features that we could add that would maybe take care of that issue? Over.
That's a good point. Yes, Val, that's a great point. So, like number 6, where the wall is on the northern shoulder there, there could be things that could be installed to prevent people on the wall. I agree with that. That may make the parking length a little bit shorter, so there might be a small trade-off, but I think, but also maybe not. That's something that we could look at, and so there's the potential for that rating to change, maybe to good over time, if we were to look at something like that. That's a good idea.
Okay.
This is Mark. And I wanted to just pipe in that, all your observations are pretty astute, and I think when we get into the design process, there's a lot of standards out there that account for some of these concerns, as far as sight distance and turning radiuses and things like that. So we're not starting from scratch when we get to that point on any of these, with any of these options in terms of trying to mitigate some of the concerns. So obviously some are way better than others, but there's a lot of standards out there, and I'm sure the design team would move forward with common best practices. So something to keep in mind. Thanks.
Good points, Mark. Thank you. I agree.
Okay. So here is our matrix as it stands. Almost there. We got one more. The final category is the environmental or cultural resource. Considerations there. So we'll walk through those options. I'll ask Omar Ortiz, our environmental specialist on the project, to talk about these. I'll hand it over to you, Omar.
Yeah, this is Omar Ortiz. I am the environmental resource specialist on the project. There were a couple of environmental concerns that apply to the Bridgeton area and alignment options, and one is to avoid impacts to the Riverward side of the levee system. The reason being is you wanted to avoid the aquatic habitat of endangered fish, salmonids, and also the critical habitat. The other part of it would be to avoid any addition of, and minimize addition of impervious surface materials, and that's to kind of minimize the increase of water quality issues or water quantity issues being conveyed downstream. Overall, all these measures I think are pretty good. They really don't have any impacts to impervious surface areas. They're really minimal, but the only one that really has an impact is number 6 on the additional work that would be on the Riverward side, that has some placement of riprap and some placement of the sheet pile. But those impacts are even minimal because they are above the ordinary high water mark of the Columbia River. So really, I rate them all good, all down the entire column, except for number 6. That would probably be good to fair. Any questions?
Oh, I'm sorry, this is Valerie. Maybe just a question or clarification. So is there anything that you've heard from the resource agencies that would maybe make consultation or coordination with them more difficult, one option compared to the other, or are they all enough similar that there's no distinction there? Over.
I think there'd be some concern from the resource agencies on the option number 6 because of that riprap placement and the sheet pile placement. I think that would be the only one of concern. It would still be something they could work with if it was the only option we had available to us. I think we have some other good options here that we're considering as well. Overall, I think the impacts are relatively the same when you look at it from a perspective.
Oh, sorry. I was just going to ask, so would there be any difference then in cost as a result of needing to do mitigation or something related to a reasonable and prudent alternative or measure under Endangered Species Act?
Yeah, that would be a potential issue of having additional costs. The closer you get to the Riverward side of impacting the river, the higher your potential is going to be for having a reasonable prudent measure that requires mitigation, so to speak. It's not actually called mitigation; it's called something else from the NIMS perspective. I guess they call it some sort of conservation measure, supplemental conservation measure. So yes, there would be a higher cost on that end, and we would have to consider that as well in our decision. Over.
So were there any other questions or comments on this category? The only other thing I wanted to point out was that from the environmental sides, I don't think that any of these options are going to be increasing the amount of runoff, where essentially there's not really any net impervious area change. So the amount of runoff that's going to be going to pump stations on the inside of the levee is going to be basically unaffected by all these options as well. So that's the end of our meeting today. The point of this was not to make a decision, but to really evaluate the different options under these different categories. I'll just stress again, it is the most important categories from the study's perspective are, one, does this actually work? Does it perform from an engineering and technical perspective? And then two, what's the cost for this option? So a lot of these different categories feed into those questions, but those are the primary metrics that we need to evaluate, but we also do need to be considering other categories here. So thank you all. I think we'll open it up to any closing thoughts or concluding ideas that folks have.
Okay, thank you, Ryan. This is Laura. I'd like to chime in on that point as well. So it did seem when we were rating things, specifically in the engineering performance criteria, Jeremy did a really nice job of speaking to risk and uncertainties, which is a very important part of our analysis. So I'd just like to make clear that in most of the technical discussions that we are thinking about risk and uncertainty as we're going through the good, fair, poor performance pieces. Secondly, thanks to the technical team, this was a great first step at developing the design options specifically for Bridgeton Road. I do think that as far as the next step goes, we'll need further verification of this qualitative discussion, and we'll be working to try to put costs on these different design options, and then we would rank them to see how they compare to the federal requirements that were required by law to establish. And I think that would be nice, and it'll play into decisions that the non-federal sponsor may have to make. So if the Corps was to land on one design option, and local sponsors then may want to work towards a different design option, that would give them an idea of how much that incremental cost might be. And so I just want to open that up to see if there's any comments or additions to any of my closing remarks. Over.
Okay, hearing none, I think we'll close up the meeting. Thank you guys again for powering through this. This was a long meeting.